It has been a privilege to watch the impact that CENSIS has had, and as somebody who really believes in tech for good, I love to be able to hear those stories, so more of that today. I'd like now to introduce someone I've known for longer than I care to admit, actually, but that's not a reflection on him and just on my age. Andy Stanford Clark, well known, I imagine, to many of us. You might get some interesting facts about him later from himself, but let me tell you about Andy. He's an IoT evangelist. He's a distinguished engineer in IBM for the Internet of Things. He's a master inventor. He's a quantum technical ambassador. Probably many other things from your bingo cards, but essentially, this guy really knows what he's talking about. And as far as I'm concerned, he's one of the good guys. Andy's going to share his story, Innovation Begins at Home. Andy.
Thank you, Sharon. Lovely. Yeah, when I first saw Paul's shirt, I thought it was one of those things where if you squint at it, some 3D picture appears. So I'll be squinting at your shirt later.
You say something rude.
Yeah, I'm sure I have no doubt. Yes. I hope you've all got your I Heart MQTT tags on your badges. A quick show of hands, who's got an I Heart MQTT tag? Almost none of you. That's dreadful. Okay, so in the coffee break then, there's these tag stands where you can go and get one. I'm expecting after the break to see everybody with I love MQTT. Who's heard of MQTT? That's better, right. Okay, so the thing that Sharon was trying not to tell you about is that I actually invented MQTT 23 years ago. So if you're using that in your IoT projects, you're welcome. And if you're not, you jolly well should be. So enough said about MQTT. Suffice to say, everything I'm going to talk about runs on MQTT, okay? And it's very much what you do with it rather than the underlying protocol itself, because that's the most important thing. So my subject is innovation begins at home, and I firmly believe that. I'm an inveterate tinkerer, electronics enthusiast. I've got a number of 3D printers, so I love building things. But the advantage of trying things out at home is that they don't necessarily have to see the light of day. You can kind of test them on the most critical audience you may have, i.e. your family. And it probably is a strong message to say, just because you can do something doesn't necessarily mean you should. One of my favorite disasters was, I wrote this really cool app on a PDA, back when PDAs were a thing, to turn on the lights. I was firmly told that the little switch on the wall is actually a much better way of turning on the lights than getting out a PDA, finding the right app, and clicking the button. Yes, but it's not as cool. That wasn't the point. So lessons quickly learned. So when I was talking to Sean about what I should talk about, as you're coming up to the 10th anniversary of CENSIS, I thought it'd be really interesting to look back 10 years, compare and contrast those with now, and then sort of glimpse 10 years into the future to my thoughts on what's coming next, what's going to be important. And it turned out, when I started looking back into remembering what I'd done 10 to 15 years ago, a lot of it was to do with smarter energy, the energy grid, decarbonisation, all of which is entirely topical today. It's like it was 10 years ahead of its time. So what I'm going to do is look at some of the things I was playing with 10 years ago, sort of 10 to 15 years ago, and sort of reflect on those. We can just think how relevant those are and how they're going to come back into vogue very, very quickly in the next few years, next few weeks, in fact. So the first one is home energy saving. I started monitoring how much power my house was using, just as a sort of an interesting number to measure in my house, because sort of quantified self thing. And so I put the data from a homemade energy clamp live on the internet, as you do. And I'm assured this thing doesn't have a laser pointer for health and safety reasons, so I can't point out things on the screen. But the little wiggly line is the fridge and the freezer going off. The big spike at 6:30 is me having a shower. Those single spikes during the day are cups of tea. You can actually get quite a lot of insight into the lifestyle and what's happening in a house just from the energy usage. Now, my family weren't quite as into this as I was. They weren't going to bring up a graph to see how much power the house was using, even though in my mind they were kind of 3/4 of the problem. So that wasn't it seemed a bit unreasonable, really. But I came up with this, the first of many glow orb type devices, so a single pixel glanceable display, and that's actually something that's been with me throughout this decade or so, and we'll see repeating references to glow orbs as we go on. But this was the very first one, and even my children were going, why is the orb red, Dad? And we'd hunt around the house finding what the high energy user was and turn that off to make sure we didn't, you could easily save a $5 overnight by turning off a heater or something being left on. So that was a very visual, tangible way without having to bring up a graph and squint at it, just to say, oh, there's a lot of power being used. It was green, amber, or red according to the different energy uses. So not content with the whole house energy use, I wanted to kind of drill down to find out what it was that was using all the power. So I instrumented my distribution panel, much to the annoyance of the energy company, and then fitted these individual appliance monitors to some of the things like dishwasher, washing machine, telly, some of the things which I thought might be the big hitters that I wanted to isolate, and then pulled those out over MQTT topics through accumulators to see how much they were using each day and each month. So to really get a good picture of what was using the power in the house. And that led to an application called the Power Pie, which essentially a pie chart of all the things that were instrumented, i.e. not the stuff in the bit at the bottom, and what they were using as a league table. And well, I guess it wasn't a shock to me, but the underfloor heating in the kitchen was using a lot during the winter, so that's just one of those things. But one thing that really caught my eye was the lights in the kitchen. Now, remember 10 years ago, we weren't all forced by LED lights. It was a lifestyle choice, and they were quite expensive at the time. So we had these banks of halogen spotlights, really, really bright. We left them on hours at a time, didn't really think about it. But actually, that was using 148 watts on average, like 24 hours of an average. So they're on about sort of, I don't know, quite a lot of the time. But that was a real shocker to me because it was second or third on the list. So that single thing alone motivated me to change to LED lighting. Now, of course, we don't need to extol the virtues of LED lighting now because we all have to buy them because you can't buy the incandescent ones. But back then, it wasn't obvious why. And it turns out that 90% of the energy use of an incandescent bulb is heat, only 10% of it is light, and LEDs kind of flip that round. So they use about 10% of the power of the equivalent incandescent one. So when I did that, the 148 went down to 14.8, and it just dropped off the bottom of the thing and was no longer of interest. There's an interesting psychological effect called the spillover effect, which when you switch to entirely LED lighting, you go, they don't use any power. So you leave them on all the time because you think they use no power. So actually they use more power because you're leaving them on all the time. But obviously, we all turn the lights off when we leave the room, don't we? Because our parents told us to do when we were children. My dad used to say, if I had £1 for every light that was on in this house, I used to go, you'd have £37.80. Smack. So having kind of wired up my own home, I wanted to kind of extend the feelers a bit. So I got involved in a community project near where I live. So I live on the Isle of Wight in a little village called Chale, and there was a project imaginatively called the Chale Community Project, which was quite an ambitious program back then. This was about 15 years ago, to help people in social housing, people who are in energy poverty. This is people who spend more than 10% of their household income on energy. Again, this is coming back into the news now. People are talking about energy poverty and what it means. So the owner of these houses, the housing association, retrofitted the houses with double glazing, loft insulation, air source heat pumps for heating, and put solar PV on the roof. And the exam question was, would the residents change their behavior to use their heavy hitting appliances during the day when the sun was shining, and therefore power them from the power from the solar panels and not have to buy it from the grid? Or would they behave as they always had done before, which is to kind of do their washing at night, use the cooker for long periods of time during the night, and so on? So they didn't know what people were going to do, but they'd heard of what I was doing at my house. It had been on the news a few times. So they said, perhaps you can come and help with this. That sounded like an interesting project. So we instrumented the homes, put some energy monitors in, and we first of all did a smart meter style display. So if you've got smart meters in your house, or a smart meter, you'll probably see a graph from your energy provider like this, very lumpy, not very detailed graph of your energy use, which doesn't actually tell you very much. But that's what we started off with. Then we kind of said, well, actually it'd be better to get some more detailed information. So we went for the high-res version, and also put some of those individual appliance monitors in so that we could see what different appliances we're using. We asked the residents what they thought the most energy-hungry devices were in their house, which is an interesting psychological study in itself. Turns out people think the biggest appliances use the most power, which isn't necessarily the case, but it's an interesting effect. So we could drill down into the energy use, and we saw some really interesting things. One of them was that grey bar at the bottom is the base load. That's the stuff that's always on. So even in the middle of the night, when there's no telly on, no lights, your house is using some power. It's stuff on standby. Now, it might be your TV on standby, little red LED, it might be the washing machine you didn't turn off, all your phones charging up, all those things using some kind of base load. And back then, 12 years ago, I worked out that if you had a watt that was on for a whole year, that cost you £1. Okay, really nice, £1 per watt per year, really easy. So in my house, or it wasn't my house, this house, there was about 200 watts were on all the time. Doesn't matter what they were, but whatever they were. So that's 200 quid a year that somebody was saying, right, I'm happy to pay 200 quid leaving stuff on standby. You might think, that's ridiculous, outrageous. You should be able to account for every single one of those watts, and anything that's not absolutely necessary, turn it off, because that's discretionary energy use, which £1 per watt per year, that's quite a lot of money. Now, that was 12 years ago. Electricity has, you may have noticed, got more expensive. The price you're probably paying at the moment for electricity is now £2.50 per watt per year. And you probably saw in the news the shock of it going up again in October, and then the government stepped in to reduce the cap. Most people misunderstand the cap. They think it's that you won't spend more than £2,500 on your energy bill. Absolutely wrong. Very badly communicated by the BBC and all the other media outlets. But I'm blaming the BBC particularly because they should have known better. But there's a cap on how much per unit the energy companies can charge you. And for the average household, which is 2,900 units of power of electricity and 12,000 units of gas, don't know why I remember these numbers, that works out to £2,500. So you can certainly have an electricity bill more than that, and you can certainly have an electricity bill less than that if you use less than that average amount of power. Anyway, so for those caps, which are kicking in on the 1st of October next week, that's now going to be £3 per watt per year. So that 200 watts that's always on, that's going to be 600 quid. So if that was my house, I'd be looking very carefully at what that base load was. Now, during this project, I got, I guess, an unhealthy obsession with fridges and freezers. Again, in the news right now, because I read an article in The Guardian, again, blaming them specifically because they should have known better. People turning off their fridges, thinking that it saves power. They probably watched the news report on their 80-inch plasma television, which uses about 3 kilowatts. But no, we'll turn the fridge off and risk getting food poisoning. Now, a well-behaved fridge is like this. It's off most of the time, and it comes on when the thermostat gets above a certain temperature. It turns on the compressor, which chills the contents down till it gets to a lower temperature. Then it turns off, and it slowly heats up, and then it just does that over and over again. So it's not using very much power. As fridges get older, the compressor gets less efficient, the seal around the door gets less reliable, so it has to come on more often in order to keep your food at a safe temperature. In extremis, this is a fridge that was we're cranking away in the garage of one of my colleagues. It's actually on more than it's off. So this is using about just under £200 of power a year. Now, you can go down Currys and buy a new freezer for far less than 200 quid. There's an interesting tipping point where if it's going to use more power in the next year, then it would cost to buy a new one. You should probably go and buy a new energy-efficient freezer or fridge. So we ran a script over the Chail project, fridges and freezers, every Sunday night, which said we basically looked for that trend as the fridges were getting older, and then they would go in and replace them. Now, if you're a fridge or freezer salesperson and you are armed with this data, what a beautiful opportunity to go and make a doorstep sale and say, look, armed with this data, I guarantee I can save you this much money over the next year. So new, interesting business models developing from this interesting IoT data. The other interesting thing which shocked me at the time was that my microwave, and this was quite an old microwave even then, it has a clock on it, as most most microwaves do. Nobody knows why they have a clock on them, but they have a clock on them. They always say 0, 0, 0, 0, don't they? Anyway, so I measured it, and mine was using 4 watts continuously. So back then, that was £4 per watt per year. Now, one year I measured how much power I used cooking things in my microwave. What do you reckon? Less than £4, £2, just over £2 a year. Actually cooking things. So the major runtime cost of my microwave was not cooking my dinner, but running the clock. Ouch. Now, that told me to turn the microwave off at the wall when you're not using it. But this was before what's called the 1 watt directive, which is one of the more useful EU directives, which came in about 10 years ago, which was that all household appliances have to use, by law, less than 1 watt on standby. So my clock on my microwave, my new microwave, has to use, otherwise it wouldn't have got the CE symbol, less than 1 watt. So that's much more acceptable. Because the problem was there was no incentive whatsoever for people to design appliances to use any less power on standby than when they were being used. They didn't have those energy ratings. I used to have a telly that used 14 watts when it was on and 12 watts when it was off. Sitting there waiting for me to click the clicker to power it back on again. Only 2 watts different. Horrific. And now, of course, they have to use less than 1 watt. And things like games consoles on standby, if they're internet connected, I won't name the manufacturer, but it uses 14 watts doing absolutely nothing on standby. It doesn't anymore, but it did back then. And there's still an awful lot of those, because they can't force you to replace your TV, fridge, freezer, whatever. They have to wait for them to live out their lives and then be replaced by new ones. So and of course, that was back then. So this is now, remember, £3 per watt per year. That'd be £12 a year just running the clock if I still had that microwave, which I'm pleased to say I don't. So all of this was very interesting. And remember, I said you can gain a lot of insight into how people live based on that wiggly energy line. It led me into a really interesting area, which is known by academics as ambient assisted living. So this is the idea of passively monitoring people in their homes to help look after elderly and vulnerable people, to make sure they're okay, to spot long-term medical trends, even short-term medical trends, if they're getting out of bed later, if they're not cooking healthily, maybe if they're going to the toilet more often, things like that, which can be useful to know if an elderly person is okay living in their home. And the idea of sort of aging in place, obviously, is very important. I don't know if Lynn's here yet, but she's going to be talking about this later. So this led me to we worked with a company called Current Care, and they had this little hub that went in the home, and then it had a number of sensors, like a door switch, a pressure mat, some of these individual appliance monitors, a toilet flush sensor, CO2 monitor, temperature sensor, and you could put these around the house and sort of use them to build a picture of how things were going. So you had a dashboard, and you could configure rules for these things. So you could say, like, if Granny hasn't had a cup of tea by 10 o'clock in the morning, that's probably bad, send me a text. So you could set up these rules, or if the door opens at 3 o'clock in the morning, call the police or whatever. So this, unfortunately, didn't actually go anywhere commercially. Very disappointing, because I think there's a huge market for it. But spinning forward 10 years, actually, I'm pleased to report there is a benefit from this. As part of my side gig, nothing to do with IBM at all, I'm part of a company called Kettle Companion, which has these little ambient orbs, these glow orb things, in my house or somebody's house, and it monitors to see whether Granny or an elderly loved one has had a cup of tea in the morning, where they've boiled their kettle. And if they haven't, the little kettle turns red at 10 o'clock, and you get sent a text saying Granny isn't up yet. So you might want to give her a call, check she's okay, pop round, whatever. So if you think this would be useful for you, go and see kettlecompanion.com. It's got a lovely little explainer video, which I'm very proud of. So that's a really nice kind of the consequence, kind of the most useful thing that came out of that ambient assisted living program. And I think we'll be seeing a lot more of this as people are wishing to age in their own homes and not go into care. So the other thing I spent quite a lot of time playing with back then, I was the CTO for Smarter Energy in IBM's consulting business, was smart energy networks. So I saw the future energy grid, the federated smart grid with local generation from PV and electric vehicle charging, and how you manage that whole grid with wind turbines and renewable generation and intermittent dispatch and all those wonderful things that energy company people talk about as being a big MQTT application. So there's lots of different devices from lots of different manufacturers all had to be integrated together to manage the grid holistically. So back then I was part of a project on the Isle of Wight called Eco Island, which was an ambitious program to make the Isle of Wight energy self-sufficient at some point, mainly through PV and through energy management. So times when the energy demand was high or the generation was low, in fact, like in the evening when there's no sun, then we turn things off in people's houses to balance out the load. Again, very topical now as we start to look at energy networks being saturated by too much PV and the fact that we have to use gas turbines, now that the oil and coal has been turned off, but we're still gas turbines, have to fill the peak demand. So in the evening, when we're all cooking our dinner and the solar PV is tailing off, if there isn't much wind, then they have to turn on all the gas turbines, so it's maximum carbon intensity for us to cook our dinner. If you've got an electric vehicle and you plug that in at 6 o'clock in the evening, you're just adding to the problem. So your EV, nice and energy neutral while it's going along, but is using very high carbon electricity to charge itself up. So if we can manage that kind of load, that becomes very important to the energy use and also towards our net carbon targets. So I've had a chance to play around with an electric vehicle. It's a strange little French car called a Mia. But it was nonetheless an electric car, so I had that for a few weeks. And I thought it'd be really interesting to play with this idea of charging it up in a grid-sensitive way to try and reduce the carbon impact of charging it. So I need to be able to turn the charger on and off. So I built my own little gadget. I melted the first one because of the high current going through it, but I bought a bigger relay and got a bigger curry box, and it all went together. So this was how I could control through software whether the car was charging up or not. So I did a little experiment. I've got a big heater at my house, so I made it so that whenever the big heater was on, the EV charger would stop charging, and also made it so it would observe a sort of dinner time embargo, so it wouldn't try and charge during the peak grid time. So it's just an interesting little experiment, and it worked quite nicely. So you can, if you've got something like some of the more advanced electric vehicles now, you can control through an app whether they're charging up or not. But giving the grid control of that is really important, because if everybody in my street gets an EV and we all plug them on to charge at the same time, then the little green transformer at the end of the street will blow up because it can't take the load. So the grid, the power company, needs us to stagger the charging through the night so that they're all charged up by the time we go to work in the morning, but they've taken their turn in charging up during the night. So this is going to be really important in the future. Now, getting hold of the data as to what the carbon intensity of generation is used to be very difficult, but now National Grid's done this thing called green light signal. If you Google for that, there's an API in fact, you can buy a green light device, which is a Philips Hue bulb, and it just shows red, amber, or green according to how carbon intensive the generation is at the moment. So basically how much gas is being used to run the turbines to generate it. Or if the wind's cranking away and the solar's cranking away, then it goes green and you get a green light signal. Unfortunately, it doesn't happen very often. But it depends where in the country you live, actually. If you live near a big wind farm, you'll probably get it more often than I do on the Isle of Wight. But there's an API that you can call. And so I've got one of these little glow orbs on my desk that shows the current carbon intensity of generation, so I can make a decision whether to put the dishwasher on or the washing machine on. But it'd be nice if that was automated, and in the future, home energy management systems will do that automatically. And one little application I've written is that when it goes to red, i.e. the maximum carbon intensity, which normally happens around 5:30 in the evening, it turns off my laptop charger. Now, it's only 65 watts, I say only, but there's a tiny contribution to the grid. But imagine if all 30 million laptops in the country simultaneously turned off at that point, we'd really, really help reduce the carbon intensity of generation. So we're actually working with a couple of companies to see if we can turn that into an application that runs natively on the laptops so that they automatically become carbon sensitive. And so they run on battery at the time when the grid needs that power back the most. They're called negawatts, so the watts that you turn off are negative watts, and that's that's an energy saving. So this idea of controlling things remotely is called demand-side management, and we did a tiny little experiment, again on the Isle of Wight. We had a government minister come down to speak at some conference for Eco Island, so we arranged this little stunt where we'd turn on all these remote loads, like electric vehicle charging up and a couple of heaters and some other things in the house, and then the minister would press the coloured button and it would send out, send out a demand-side management instruction from cows at the top down to the various houses to say, can you turn off your things, please? And they'd all report back saying, yes, I've turned that off, and the graph would go down, and we could prove that we'd saved at 4.5 kilowatts or whatever it was, tiny amount, but it gave the minister a sense of power that they were actually controlling the grid and helping reduce the carbon footprint of the Isle of Wight, so that was really good. We're going to see a lot more of that stuff, so HEMS, home energy management systems, are kind of part of that equation. Also had a chance to play with hydrogen power during that era as well, so that was really interesting. We did an Innovate UK funded project. We were working with a company called ITM Power in Sheffield. They build these big electrolyzers, top left. They take water and put electricity in to split it apart into hydrogen and oxygen. You store the hydrogen under pressure in tanks, and then you can use it to fuel hydrogen-powered vehicles. There's two types of hydrogen vehicle. There's FCEVs, fuel cell electric vehicles. So a fuel cell takes hydrogen and oxygen, recombines them over a catalyst to produce electricity. And that one up there has got a fuel cell motor under the bonnet. And there's also the other one is HICE, hydrogen internal combustion engine, where you basically burn hydrogen as a fuel, and that's what the boat did. We modified an outboard motor so it actually ran on hydrogen rather than petrol, and somebody sailed that boat around the Isle of Wight powered by hydrogen, which is pretty cool. And at the same time, we drove the fuel cell electric vehicle around the outside of the Isle of Wight as well, so we've done the kind of on the land and on the sea powered by hydrogen stunts. So that was all very interesting. I learned a lot about hydrogen and how to manage it and how to monitor it and all kinds of stuff. And at the time, I thought it'd be really cool to build what turned out to be the world's first and only hydrogen-powered Raspberry Pi. So I had a presentation which I gave about this hydrogen project, which automatically booted up in presentation mode when that Pi was turned on. So I'd come into a conference, plonk my Pi down on the lectern, plug in the HDMI, connect the hydrogen cylinder, and it would boot up and go into the presentation powered by hydrogen, which is super duper cool, and always a great crowd puller at conferences. I've mentioned ambient displays a few times, these glanceable displays, and this has been a real journey for me over the last 12, 15 years. So I call them glow orbs, and it started off with the one that I did for my house way back on the first slide. They were actually inspired by a guy called David Rose at MIT Media Lab, where I used to hang out in the 90s. He wrote this amazing book about IoT called Enchanted Objects, which is essentially how IoT brings enchantment to everyday objects. And this kind of glanceable display was one of those products that came out of that. But my own glow orb journey has gone through a lot of evolution. The one with the cardboard box predates when I got my 3D printer, so I had to build a cardboard prototype of it. I remember taking it through Southampton Airport once, and the guy said, this looks a bit homemade. I said, thanks. It is, actually. Anyway, we eventually settled on the Glow Orb Classic, which has a ping pong ball attached to the top of it, and then the current version, which is the Squorb, the square orb. I actually sell these, so if anybody wants a glanceable, they're MQTT connected, they use Wi-Fi, and you just send them a color, like #00FF00, and it turns green. So it's a really nice single pixel output display. There's hundreds of them out there, people use them for all kinds of things. So what of the next 10 years? So I quite often get asked this question, and obviously there's a gazillion things I could say, from quantum computers through to graphene through to whatever. But I've picked three things that are sort of very personal to me. So one of them is digital twins, which you may have heard of, which is where you build a software simulation of a physical system, and you basically connect the digital twin to the physical system using MQTT and Internet of Things technologies, and to bring it up to speed. And then you can kind of turn the knob and run time forward with a whole load of possible what-ifs, so you can play out future scenarios in software, in silico, before you do it to the real thing. I've taken this one step further with what I call physical digital twins. And the idea is that you take some characteristics of the original physical system, reimagine them back into the physical world using data from the digital twin in the middle to show things that were either averages or inferred or interpolated or extrapolated from the data coming from the physical system. So you're benefiting from the data in the digital twin. I've got a whole load of these things at my house. The house one is this is Hursley House at IBM near Winchester. It shows a live heat map, literally, of the building, so that the site manager can see at a glance the balance of heating and cold through the house. And as the sun goes around, that pattern shifts through the day. I've been working the last 3 years with the Mayflower autonomous ship, which is a whole other presentation in itself. And I've got live telemetry coming from those, actuating little servo motors to show the rudder position and the throttle, telling me what the Mayflower is doing. So just ways to me to make it very glanceable and very sort of very tangible, linking back to the real world. So digital twins and physical digital twins is my first prediction. 3D printing is going to be much bigger than it is already. You might think it's big already, but we ain't seen nothing yet. I've had a 3D printer for about 8 years now. I've actually got 3 of them now, oddly enough. Long story. But I use them for all sorts of things. During the first lockdown, I was part of a huge distributed factory printing visors for PPE for the NHS to fill the government shortfall in providing this essential life-saving equipment to our hospitals. So that was a good thing to use our printers for. I printed several hundred, and we did hundreds of thousands of them between the distributed factory amongst our homes. I use it for more eclectic things, like this is one of the connectivity maps for the qubits of one of IBM's quantum computers, so I visualized it in 3D and actually made some coffee coasters out of it. That's a nice use for it. Through to very mundane things like square peg into round holes adapters, like for inflating a child's toy. If the adapter doesn't quite fit, we can 3D print a nozzle converter to link it all up. So 3D printing for just-in-time inventory management, printing things at the site point they're needed rather than having to hold inventory in stock. And my final one is virtual and augmented reality. So VR's passed a really interesting tipping point in the last 2 years. First of all, the headsets are affordable. They're hundreds rather than thousands or tens of thousands, as they were recently. And you don't feel sick when you use them. Those two things have combined to make this now technology that's really going to take off. I bought a Quest about 18 months ago and spent about 6 months obsessively writing programs for it, because it was just really, really cool. I did some work to bring MQTT feeds in and out of the virtual world. So one of them was my Christmas light setter. So in the virtual world, I could set the color of the virtual Christmas lights, and then that string of real Christmas lights on my banister would actually change colors according to what I was setting them in the virtual world. That was quite cool. And then living on the Isle of Wight and being obsessed by the ferries, I've got a live ferry feed. I know they're only blocks, but they're actual ferries, and you could jump onto one of those and ride it across the Solent in real time with the AIS data coming from the ferries. So all good fun, and this is going to be really big in many different industries and many different domains. So those are my predictions for the future. I hope you agree. Innovation really does begin at home, and thank you for listening.